Hello guys, welcome to another section of Math. Indefinite integral of x over square root of 1 minus x raised to the power 4 dx. This problem here, I would say, is very simple to solve because this x here is making it so. Why? Because if I can manage to rewrite this one in such a way that the derivative of this one will give this x here, it can take away this x here at the end of the day, and then the problem becomes something that we all know better. But if this one is not there, the problem is different thing on its own. Maybe it won't be as I'm saying, or it won't be the way I'm going to approach this one. But because this x is here, I'm saying it's simple to solve because we can find a way to deal with this, or we can find a way to rewrite this, differentiate, get this one, and which at the end of the day will take away this x, and the problem becomes very simple to solve. Alright, if you want to know what I'm talking about, you just follow along. Let's get started. First, let's write our solution. Alright, so let's bring this one down here. Good. So as I said, this x here makes the problem very simple for us because we can rewrite this x raised to the power 4. Yeah, we can find a means to rewrite it, which at the end of the day, when we differentiate that, it will take away this x. We will get x as part of the derivative result, which at the end of the day will definitely cancel out with this x up here. Okay, and when that x is gone, the problem will surely become something that we are more familiar with, or that we all know better. Okay, so how are we going to rewrite this one as I'm saying? Well, x raised to the power 4, it can be written as into bracket x squared all raised to the power 2, x squared all raised to the power 2, x squared all raised to the power 2. When we do that, and then the moment we do that, that one will definitely come out with the approach to use, because if we do that, you're gonna get x squared all raised to the power 2, and to take away this x, we have to differentiate that x squared. And how are we going to get that x squared to differentiate? That is by substitution. Okay, so we are first going to rewrite this one, and then after we are done rewriting this one, then we do substitution to take away this one. Okay, so actually rewriting this one is going to tell the approach that we are going to use. I hope you are not confused. Alright, you just stay tuned to the very end of this video and you get to know what I'm talking about. So let's rewrite this one. X raised to the power 4 can be written as x squared all raised to the power 2. So let's write that one. Good. Now that is what I was talking about. X squared all raised to the power 2. Now when we open this bracket, it's the same thing as well. This one up here. Okay, so this one has been all written as this, and we all know that if we can get this one to differentiate, we will get what? X at the end of the day, and that X that we are going to get as part of the derivative results can definitely eliminate this one. And when this one is gone, whatever that we place this one will be all squared with this, and the whole of this problem will become something that we are all what familiar of, or that we all know better, that we can easily even tell answer to without even further doing any workings. Okay, so to get this X, or to eliminate this one, we have to do what? Substitution. So you're gonna let u be equal to this u squared here. If we had told the approach initially that you're going to use, you have been wondering how the approach is going to be done. That is, are we going to let the whole of this be equal to u, or maybe this one, or this, or what, or even the whole of this? Maybe you can do so, maybe depending on how good you are with your algebra or skills. Maybe, yeah, if you are very good with algebra, dealing with complex calculations, who knows, maybe you can do that. Okay, but managing to rewrite this one has even suggest the approach that we should use. That is why I said this X up here is making the problem easy to solve, because when we rewrite this one, doing that will just suggest the approach that we will use, and when you use the approach, it will take away this X here, and the problem will be very simple. Okay, so let's do our substitution. Okay, so we are going to let u be equal to x squared. Okay, so when you do that, now let's differentiate. When we differentiate, you're gonna get the u, and when we differentiate, you're gonna get 2x dx. So du is equal to 2x dx. Now let's find dx. Let's divide both sides by 2x. We are not going to find anything to replace this x in the u world, because we already having another x there, and that is the reason why we are not finding anything to replace this x in the u world. Okay, so this dx here is equal to 1 over 2x du. Now dx is equal to this, and then x squared is equal to u. Now let's put this into the integrals, see what we are going to get in the u world. Don't worry about this x here. So as I said, differentiating this one has helped us to eliminate this one, because after differentiating this, we had 2x, and here is the case we already have another x here. So this and this is definitely going to cancel out, and when that is done, the problem is very simple. Okay, so here this and this will cancel out, and when this x and this x is gone, 1 over 2 here is constant, and that one can be written at the back here, and our problem will just be 1 over square root of 1 minus u squared. Good. So this one here, 1 over square root of 1 minus u squared, this indefinite integral is something that we are all familiar with, or that is something that we are all those who have read calculus, they easily know answer to, because most of the time it's part of the integral formulas that we know. Sometimes when you get some integral formulas, say integral of this one is equal to this, integral of this blah blah is equal to this. When you get something like this, the answer to this one is just sine inverse of maybe u, or sine inverse of x. Okay, it depends on the world that the question is in. If this one appears to be x, it will be sine inverse of what? X, and this one will be what? Sine inverse of u. If this one is k, it will be sine inverse of what? K. That is what the answer to this integral here. We are done, that's all. But I'm not ending here. When you reach here, you can write your answer directly as I said, because that is what you are going to get at the end of the day. But we know the answer is just sine inverse of u or sine inverse of x. But why do we say indefinite integral of this one is what? Sine inverse of what? U, and not, let's say, cos inverse, or let's say tangent inverse, cotangent inverse, or any other ratio by what? Sine inverse of u. Do you know why? Well, I've already told you the answer is yes, sine inverse, but I'm not stopping here. I'm gonna carry on to show you why is it what? Sine inverse of what? U. Why? The rationale behind, the reason why they say the indefinite integral of what? 1 over square root of 1 minus u squared is what? Sine inverse of what? U, or sine inverse of what? X. Okay, so to solve this problem here without writing the answer straightforward for you guys, we have to use what? The trig substitution. The trig substitution. I don't know, maybe partial fractions can work out for you, but you can try that one. But here I'm going to use trig substitution to solve this problem. Okay, so we're going to do trig substitution, and before we can get to know the ratio that is going to replace this that is going to be used in this integral, we first have to draw our right angle triangle. Okay, so let's draw a right angle triangle. All right, this is our right angle triangle. Now I'm going to position my angle theta here. So let me bring my angle theta. Good. But the next thing is to write this one here on the size of the triangle here. But how is it going to be done? Are we going to just write it anyhow? 1u square blah blah? How? Well, to write this one on the size of the triangle, first you need to consider something. Check what is inside the square root. Is it subtracting or is it adding? If it is adding, then it means that what is inside the square root, the element, the numbers and the variables inside the square root is going to appear on this side and then this side. Why? Because from Pythagoras theorem, this side square plus this side square will give us what? This side. So if what is here is adding, either square root is on it or our square root is not on it, just put it in your mind that the numbers or the variable that is inside the square root or that is here is going to come on this side and then this side. Okay, then, or if it is subtracting, here is where the problem lies. If it is subtracting, then you have to take your time a little bit. You have to check how the subtraction is being done. This one is 1 minus u squared. 1 minus u squared. So we are subtracting 1 from u, which means that even from the Pythagoras theorem, here is a, b, and then c. To get something of this nature here means we are either looking for one of the sides of the triangle, either this side or what? This side. Okay, so to get this side, it is what? This side squared minus this side squared, then we take square root of that. To get this side, it is this side squared minus this side squared, and then we take square root of that. That is why I said this is where the problem lies. So since we are subtracting u from 1, meaning this one should be on the what? The hypotenuse side, so that whatever that this one will be positioned to at the end of the day, when we apply the Pythagoras theorem, it will what? Be subtracted from this one. Okay, and also if this one appears to be subtracted from what? U, then we will position our u here. The moment it is what subtracting, what you have to think of, just look at how the subtraction is being done. The number of the variable that something is being subtracted from is going to come on this hypotenuse side. Okay, so here we are going to write 1 here, and then here is the problem. The question is, where should this u, not u squared, where should this u be positioned? Should it come here or come here? Well, that one depends on you. For me, I would say always make sure you do it in such a way that the ratio that you're going to get, definitely the ratio that you get, you are going to definitely what differentiate it. So if you do it in such a way that the ratio that you're going to get is very difficult, maybe some kind of a little bit tedious, differentiating it will also what make it tedious. Okay, so always make sure after you are done writing it on the triangle, make sure the ratio that you get, I mean, when I say the ratio that you're going to get, I mean the ratio that you're going to put into this one is what very simple and easy to differentiate. Okay, if you can do the algebra, then you can go for what the complex ones. Other than that, make sure you always stick to the easier ones. Okay, so 1 will come here, and then you put our u here. Somebody may also put the u here. Maybe you can do that. When you do that, the whole of this one will just come here, and then when you do that, I think maybe you might end up getting the same ratio. But here in this video, I'm going to position my u here. Okay, and when I put u here, to get this side is going to be 1 squared minus u squared. Then we take square root of them. When you do that, this one here is going to come to this side. Okay, so let's write our u here. Now let's bring our 1 here. Now the whole of this one is going to come here, because 1 squared minus u squared, then we take square root of that to what give us what this side. Okay, good. Now that we are done writing it on the triangle, the next thing to do is to get our what ratio, to find out what ratio is going to replace what, or is going to be used in the integral. Well, to find out, they're going to apply what the ratio formulas. First, let's start with sine. Sine is what so that is from trigonometry. So it is what opposite over hypotenuse. So what is the opposite? This side is our opposite, and this side is our hypotenuse. So sine theta is equal to u over 1, which will give us what? U. Okay, all right. Let's try another one. Cos theta is equal to, cos is equal to k. That is adjacent over hypotenuse. This side is what? The adjacent. So that is square root of 1 minus u squared all over 1. So when you pick cos theta, that is going to give us what? Square root of 1 minus what? U squared. And you see, after writing it on the sides of the triangle, we have gotten a ratio that is going to replace the whole of 1 over square root of 1 minus u squared. And you know, the reciprocal of cos is what? Secant. So when you pick secant theta, you're going to get 1 over square root of 1 minus u squared. So you see, the whole of this can be replaced with what? Secant theta. But I'm not going to do that in this video. Okay, so here you're going to pick what? Sine. You're going to pick what? Sine. So you're going to let, when you pick sine, it's going to be u over 1. So sine theta is equal to u over 1. And mind you, here we are having square root of 1 minus u squared. When we come here, cos theta is what? Square root of 1 minus u squared over 1, and which is what there. So when we get back to this integral that we are solving, we will not bother ourselves replacing this, replacing sine theta or here, because the whole of this is 1 is just what? Cos theta, and it can be seen from here that cos theta is equal to what? This side over this side, at the end of the day, which will give us what? This, which at the end of the day, also when you substitute sine theta into this one, compute at the end of the day, find the square root, we are still going to get the same what cos theta. So why should we worry ourselves for doing that? Okay, so now let's form our ratio. Sine theta is equal to u. Now let's differentiate. When you differentiate, you're gonna get what? Cos theta the theta is equal to the u. Cos theta the theta is equal to the u. Now, as I said, let's find another ratio that can replace what? The whole of square root of 1 minus what? U squared. Now, I know that cos theta is equal to square root of 1 minus u squared. This one is what? Over 1, but the whole of this over 1 is the same thing as well. This one, okay? So when you go back to the integral, you replace this one with this, du with this, and that will be all, because we don't want to replace what? We don't want to put the sine theta into the square root and then compute. That will take maybe a little bit to do. So we want to go fast. So let's put them into the integral. Okay, so when you do that, you see, doing sketching the right angle triangle and using to generate the ratios has made the problem very, very, very simple. You see, so now when here we are having the cos theta is all because of the du. Du is equal to cos theta d theta, and then when you come to this delimited position, we are having cos theta all because of this one. When you put sine here, it's going to be 1 minus sine theta squared, and that will give you cos theta squared. And when you take square root of cos theta, just going to go what? Cos theta. Okay, so that is how come we are having this, and this over this will give us what? 1. Now this one will just give us what? Sine theta. Sorry, this one will just give us what? Theta. Because this one is 1, and we are integrating with this one with respect to theta. If this one is what? X, it will be what? X. If this one is what? If this one is any variable at all, it will be what? Any variable at all. So if here is p, it will be what? P. But here is what? The theta. So here will be what? Theta. Okay, so you're gonna get what? 1 over 2 theta. 1 over 2 theta. Now that is the answer to the integral question in the theta world. If this integral appears to be definite integral, you will not bother yourself going back to any world at all. You will just find what values were given for what? Theta. Then you will just replace them here, and then we compute the value at the end of the day. But this one is what? An indefinite integral. And with indefinite integral, we always have to go back to where we came from or how it was presented to us. Okay, so let's go back to the x world. But going back to the x world, we know that this sine theta is equal to what? U. We know that sine theta is equal to what? U. And also u is equal to x squared. But first, let me talk about this one. Sine theta is equal to what? U. Good. But the answer that we have is what? 1 over 2 sine theta. 1 over 2 what? Theta. So how are you going to get this what? Theta here? It's very simple. From trigonometry, angle of elevation, depression, to find them, just take what? The sine, the inverse of what? That ratio. So how are you going to get this theta? From this small equation here, let's take it as that. From this small equation here, we have to take what? The sine inverse of both sides. That is the sine inverse of this and the sine inverse of that. When we take sine inverse of this, sine and sine inverse will cancel out, and it will give us what? Theta. So you get theta is equal to the sine inverse of what? U. Then because it's something that we all know that I don't want to waste time on, I decided to bring what is going to replace what u in the x word directly for you, so that I will write the answer directly for you. So when it is written this way and the answer is just written directly, you will know why. Okay, so here from here you're gonna get theta is equal to sine inverse of u, and we know that u is equal to x squared, and that is going to give us for sine inverse of x squared, and we will just multiply by the half, and that will give us 1/2 sine inverse of what? X squared. You see, sine inverse of what? X squared. So the problem that we solved gave us the sine inverse of what? The x squared. But the one that I wanted to show you is what? Sine inverse of u. Here is x squared because the problem that we were solving, we made what? We substitute what? This x squared with what? Another variable. So if the problem was like 1 minus x squared, then our answer probably will be just be sine inverse of what? X. You know, where we were having 1 over square root of 1 minus u squared, the answer that we came to get was what? Sine theta is equal to u, and when we take sine inverse of u, so we're gonna get what? Theta is equal to sine inverse of u. So that is the main reason why they say when you have problem of 1 over square root of 1 minus u squared is equal to sine inverse of u or sine inverse of what? X. But because of the nature of our problem, this is how our sine inverse will look like. To be sine inverse of what? X squared. Okay, so that is actually the reason why they say the indefinite integral of 1 over square root of 1 minus u squared is equal to what? The sine inverse of what? U. Okay, so the answer to the integral question is 1/2 sine inverse of what? X squared. Okay, so let's end it. Therefore, indefinite integral of x over 1 minus x raised to the power 4 is equal to 1/2 sine inverse of what? X squared plus 1 over sine inverse of x squared plus c plus c plus c. Okay, all right. It is plus c. Okay, the answer is 1/2 sine inverse of 4 x squared plus what? C. That is plus what? The constant that we always assume is what? Attached. Okay, all right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.